Right guys, let's have a go at 7 then. We've got y equals 3x cubed minus 4x plus 2. So let's differentiate to find the turning points then, shall we? dy dx. 9x squared, yeah? Minus 4. Nothing else. 2 goes to nothing. So let that equal 0. Everything's on ground level, so nice thing is all we need to do now is move the 4 across the equals and flip the sign. Then move the 9 from times on one side to divide on the other. 4 over 9, if I can write it correctly. Then to undo a square, you square root, don't you? Because this is the rule here. X to the a to the b is equal to x to the a times b. So if that's a 2, then you need a half. To get 2 times half is 1, wouldn't you? So to undo a square, you square root. If that were a 3, you'd need a third. To undo a cube, you cube root. Okay, power third is a cube root. So here we've just got square, so we square root both sides power half, and then we'll get back to x. So square root of the left. So power half both sides then. So on the left you'll have x. The square root of 4/9. You're going to get a plus and minus pop out, aren't you? And we can write power half as square root. And tap that in a calculator if you need to. We don't need to really, but we can do. So let's just do that then. I'll just bring it over here. Get it in shot. So we want 4/9 fraction. Let's try it here without the bracket, shall we? 4/9 come out of the fraction, and then we want power. 0.5. I could have written it in various ways. I could have done square root. Let's see what we get here. 2/3, yeah, which is what we expected. Or 0.67. Okay. So we get 0.67 then. So there's our turning points, plus or minus. So put a little minus or plus there. Okay, so there's the input then. So at x equals 0.67, what's the output? Y equals 3 times x cubed minus 4 times x plus 2. And our input value is 0.67 for the x, isn't it? And 0.67 for the x, okay? Tap it in the calculator. What do we get? Let's do that then. Run through that. 3 times bracket 0.67 bracket power cube back to ground minus 4 times just 0.67 on its own, isn't it? So that's okay like that. Plus 2. 0.22. Yeah? Let's just quickly have a look at that. 3 times 0.67 cubed, which we've done there, minus 4 times 0.67. Yeah, that's fine. Plus 2. And we did equals, and we got 0.22. Good. So there's 0.22. Okay, that's the output. And then the other one, at x equals minus 0.67. So what's nice here is we can just toggle the calculator, can't we? Y equals, and let's just go back to our calculator then. And if we just toggle back through the positions, and we've put a minus there, because it's minus 0.67, isn't it? And go forward, and then the next place that input happened was just here. So I'm going to have to put, what I'd like to do is put a bracket really, and then put a minus, because that looks better, and then close the bracket. Alright, equals 3.78. So I'll put that down here. There we go. So there's our turning points then. Are they max or mins? Right, well I'll just work that out up here. So d2y then, y dx squared equals, differentiate dy dx, you get 18x, don't you? So what does that equal? 18, when x is 0.67, what's it going to be? So x equals 0.67. And we've also got x equals minus 0.67. 67, okay? That's what that's supposed to say there. Alright, so you got 18 times something. That's positive. 18 times a positive thing is positive. So the top value positive, which is all we're interested in, that's a min. And 18 times a negative value, which is what this input is here. So 18 times a negative will be a negative. So that's all we're interested in really, so this will be a max. So we can see by inspection then that when x is 0.67, so let's just do a little sketch here. Here's our naught, here's our input, here's our output. Now we said that the turning point happened at 0.67 input, and the output then was 0.22, which is here, just a smidge above the y-axis, the 0 axis. So we don't know whether it's max or min until we look at the next piece of the jigsaw. And the other thing we said was at minus 0.67 here. So we had the input of minus 0.67 and the output was 3.78, which is considerably higher, isn't it? And this value is, I'll put it over here for room, 3.78. And again, we didn't know whether that was a min or a maximum. Then we looked at the second derivative, and we noticed that when x is positive, 0.67, we create a min. So this one is a min over on the positive side. So a min, we'll get rid of that line underneath. And the other one was a max, wasn't it, on the negative side. So we can get rid of that part of the thing. Agreed? Whoop! Oh, bother. So I better put that back in, haven't I? So there's the coordinate, and we said it was a max. Yeah? So what have we got then? We got a min and a max. So the curve can't do anything other than come down, go to a minimum, go to a maximum, and come back down after that. Let's label the curve then. Y equals 3x cubed minus 4x plus 2. There we go. And that's the curve there. Okay, and there's the picture. Now let's go to a calculator, a graphical calculator, and we're going to type in the actual function, yeah? So let's have a go at that. So what have we got then? We've got, what was it? 3 times x cubed. So 3 times x cubed, yeah? And it was minus 4 times x. 4 times x, yeah? Plus 2, wasn't it? Let's enter that. And you can see it's the same. I mean, the scale's different because it goes up and down, but see the 0.67s about there and there. And then see it was a smidge, and then it was 3 point something. So that looks right. You could change the settings here, the x range and stuff, but that's the problem done then. Good, we're happy with that. So let's go on to the next problem. Great.